Good afternoon. My name is Targo Kalamees and I'm from Tallinn University of Technology from Estonia. My presentation today is about circular renovation for decarbonisation of European building stock. In Estonia, the proportion of buildings in the total energy consumption is significantly higher than the EU average, around 50%. About 70–80% of energy used in buildings is used for heating and cooling. To decrease these large numbers, we have to insulate and ventilate our buildings much more efficiently. The Energy Performance of Buildings Directive aims to renovate the national stock of residential and non-residential buildings, both public and private, into highly energy efficient and decarbonized building stock by 2050. There is need for cost-efficient transformation of existing buildings into nearly zero-energy buildings. In Estonia, more than 140,000 buildings and 54 million square meters await for renovation within next 30 years. Calculations show that the average renovation delivery must increase by 3 to 5 times. Using current technology, construction sector is unable to increase the renovation delivery. Therefore, technological change from on-site to prefabricated off-site renovation is required. The first pilot is already done in the campus of Tallinn University of Technology. Horizon 2020 project Drive Zero will use a circular renovation. So, why did we start with Drive Zero? Because the embodied energy in buildings accounts significant amount of buildings' life cycle energy. 25–30% of waste generated in the EU comes from construction and demolition. The following 3 strategies will be used for circular renovation of existing building stock. First, reusing and recycling locally available materials by urban mining, for example bricks, concrete, glass, window frames, etc. And secondly, by using renewable environmental friendly materials, for example wood, hemp, cellulose, etc. and using bio-based engineering materials like timber frame. 7 live study and demonstration cases in 7 countries representing all climate zones in Europe will demonstrate the working of validated and evidence-based operation of Drive Zero holistic circular renovation package and supporting business models. So let's move now to the Estonian pilot. Here it is. It's typical apartment building constructed by aerated concrete large blocks. By using the circular and prefabricated insulation element, we will decrease the heat loss of the building envelope and the energy performance value will decrease about 50%. The deep energy renovation with prefabricated circular elements will be used for Estonian pilot. Prefabricated timber frame insulation elements to be installed into existing envelope. Windows will be installed in the factory conditions and ventilation pipes will be installed into insulation element. From circularity point of view, we will use bio-based frame, finger joints to minimize waste. Insulation is cellulose and mineral wool, and we will use a lot of reused materials. We also tested the performance of prototype in the real climate conditions. Prefabricated timber frame insulation element was mounted onto the existing wall. Hydrothermal performance was measured at 1 hour intervals at different points of external envelope. Calibrated simulation model was later used for hydrothermal analysis and design. The dry-out capacity and mold growth were used for criteria. The measured and simulated moisture content of existing aerated concrete external wall before installation of insulation elements is shown in the figure left. Good agreement between method and simulated results allowed to use this model for future simulation. We can see that moisture content on the external side is much higher compared to internal side. This is because of driving rain and higher outdoor relative humidity. Moisture distribution at different depths of external wall is shown on the figure left. Moisture distribution at different depths of external wall during 4-year period is shown in the figure right. We can see that the moisture content is higher at the external surface, but this is different at different years. After heavy rain, moisture content stays high during long period. The insulation element depends slightly on the original wall, but nevertheless you can use it both for aerated concrete large block or prefabricated concrete large panel. It's important to notice that the initial moisture content of original wall is important parameter to measure before installing the prefabricated insulation element. We simulated the hydrothermal performance at different initial moisture content that is based on the realistic measurements. We can say that another parameter for insulation element is year-end vapor barrier. The year-end vapor barrier could not be too vapor tight because the initial moisture from original wall cannot be dried out quickly. If it stays too long to the wall, mold growth could start. So let's move now to the results. On this table we can see the summary of simulation results. Different points are presented by different numbers. Here we have different vapor barriers, and here we have different insulation seasons. The green means that there is no mold growth. The yellow means that there could be minor mold risk, and red it's high mold growth risk. So we have to select our choice where we have much more green colors. The best choice for a wind barrier based on hydrothermal performance is mineral wool because of its high thermal resistance and water vapor permeability. Fiber cement board and gypsum board could be also for wind barrier, but there are already some warnings because we can see yellow color here. So what about cost? On these tables we can see cost of the insulation element depending on the wind barrier layer and facade system. Cost of the insulation element is around €100 per facade square meter, but it depends strongly on the facade material. Facade material influences the total insulation element by 1/3. If we compare hydrothermal performance at different wind barrier, then we can say that solutions that are cheaper, there are some mold growth risk. So selecting the best wind barrier materials, we can stay on the moisture safe level. So what kind of impact our insulation system has? The use of prefabricated circular multifunctional renovation elements have potential to reduce cost, reduce renovation time and disturbance of occupants, and at the same time to improve the quality and performance, both in terms of energy and indoor climate. The renovation of homes and working places improve the living and working conditions of approximately 80% of Estonian population. If you are interested to read more about hydrothermal performance of prefabricated circular insulation elements, then here you can see some literature. The first paper is about the effect of thermal transmittance of the building envelope and material selection of wind barrier on moisture safety of timber frame exterior wall. The second paper is about the influence of moisture dryout on the hydrothermal performance of prefabricated modular renovation element. The third paper is about the realization of nearly zero energy renovation with prefabricated modular elements. The fourth paper analyzes the moisture safety of nearly zero energy renovation with prefabricated timber frame insulation elements. And the last paper is about performance assessment of prefabricated elements for deep energy renovation of apartment buildings. So thank you for your circular and prefabricated renovation.